Alright, you are welcome back to Introductory Mathematical Analysis A. And again, we are still in chapter 8. In the last video, we started with chapter 8.3, but now we are going to be going into chapter 8.4. Chapter 8.4. In chapter 8.4, we'll be dealing with probability. The topic of chapter 8.4 is probability. Alright, in dealing with probability, we want to talk about what we call equiprobable spaces. Alright, number one, let's have this definition. S is called equiprobable space if all events are equally likely to occur. They have the same equal likeliness of occurring. That is what we call equiprobable spaces. For example, in a sample space of a die 1, 2, 3, 4, 5, 6, they have equal likeliness of occurring. So if I say, what is the probability of a 1? Probability of a 1 is 1 over 6. What is the probability of a 3? Is still 1 over 6. You see, what's the probability of a 3? Is still 1 over 6. Alright, so they have equal, they have equal likeliness of occurring a 3. Okay, it's still 1 over 6. What is the probability of a 5? Is still 1 over 6. Alright, so that is what we call equiprobable space. Now, the probability of a simple event is just 1 over the total of it, which is n now is the total we have there, which is 6. In this case that I have mentioned before, is 1 over 7, so n will be 1 over 6. Alright, let's see this definition. If S is a finite equiprobable space, probability of event E is just the sum of all the events that make up E. So we have probability of S1 plus probability of S2, probability of all Sj, depending on the number, or what is J, depending on what we have as J. Okay. So, but in finding probability, take note of this definition. Probability is just simply the number of that event over the number of the sample space, which is the number of the sample point. That is just the basic definition of probability. Probability is the number of E, the event E, over the number of the sample point. Like in these that I've showed you before, if the sample space is this, alright, so I want to find the probability of a 1. How many 1 do we have here? Just 1. Okay. What is the total? That is the sample space, which is 6. Okay. So the event 1 is what we are looking for. And how many event 1 do we have here? Is just 1. So the same thing, probability of a 3. How many 3 do we have here? It is just 1. What is the number of the sample point here? It is 6. So that's why we come about 1 over 6, 1 over 6 for them. Alright, let me give you another sample space. If I have another sample space as this, alright, this is another sample space, and then I want to find what is the probability of a 1. What is the probability of a 1? How many 1 do we have there? That is 2. all over, what is the samples point? How many sample point? 1, 2, 3, 4, 5. So that will be 2 over 5. What is probability of a 3 here? Is just 1 over 5. Okay, because 3 is just 1 there. Okay, hope you understand that concept. All right. Now let's go through this example. 2 fair coins are tossed. Determine the probability that A, 2 heads occur. B, at least 1 head occur. At least 1 head occur. Okay, 2 head occur, 2 coins are tossed. Remember, we have this sample space before and we can still generate it. When 2 coins are tossed, a coin has a head or a tail. Okay. Then when we are dealing with 2 coins, we are dealing with 1 coin a head or a tail, the second coin a head or a tail. So we can have the possible outcomes. The possible outcomes give us this sample space where the first one is a head, the second one a head, first one a head, second one a tail, first one a tail, second one a head, first one a tail, second one a tail. Okay, you can order your own differently, but you must get all of these that are there. Okay, all right, so now we want to find the probability of a head, probability of a head, 2 head rather, probability of 2 heads. Okay, so first we can find the event. What is the event of 2 head? The event of 2 head, let's call an event E 2 head. Event of 2 head. Okay. Okay, which this gives us 2 head is just this one. Okay, that is the event of that. So if I want to find the probability of E now, it will be how many 2 heads do we have? Just 1. All over, what is the total of the sample space? 4. So that is 1 over 4. So that means the number of 2 heads that we have is just 1. Okay. This make one outcome. This also is another outcome. This also is another outcome. This also is another outcome. So we have 4 outcomes there. So the event of 2 heads is just one of the outcomes, which is 1 over 4. Okay, that's fine. So let's go. The second one is at least 1 head occur. At least 1 head occur. Okay, let me do like this again. At least 1 head occur. If event F is at least 1 head occur. Okay, let's find at least 1 head. At least 1 head means 1, 2, like that. Okay, and so on. At least 1. It must not be less than 1. It must be greater than 1, but must not be less than 1. It could be greater than 1, but it must not be less than 1. Okay, but in this case, the highest head we have is 2. So when you say at least 1, we mean, when we say at least 1 head means 1 head and 2 heads, and or 2 heads. Okay, 1 head or 2 head. Let me put it that way. We mean 1 head or 2 heads. Okay, when we say at least 1 head. So let's count. So event F should be at least 1 head, at least 1 head. Okay, at least 1 head. So how many do we have there? This is 2 heads, so we take it along because there's 1 head there, at least 1 head. This is 1 head, we take it with us. This is 1 head, we take it with us. So this one has no head, so we don't have that one. So when I want to find the probability of F now, how many outcomes do we have in F? 3. How many outcomes we have in sample space? 4. So that's why the probability of F is 3 over 4. Please make sure you understand. Make sure you understand. All right, now let's look at this example again. Find the probability of being dead a full house. in a poker game. Okay, a full house is 3 of one kind, a full house is 3 of one kind, and 2 of another. Okay, such as 3 queens and 2 tens. Okay, express your answer in terms of combination. You remember this combination? You remember this combination? This combination means combination. It means n factorial over n minus r factorial r factorial. That's what this combination means. Okay, and it means selection. Okay, selection. All right. So now in a full house, we are dealing with three type of one kind and 2 of another. Now we are now talking about a card in a deck of cards. You must be able to know what is there in a deck of cards. So in probability, 3 things are important to you to know. Number 1, the outcome of a coin. Number 2, the outcome of a die, the possible outcome of a die. Number 3, we have the possible outcomes of a card. These are basic things you must know in probability. Other things might be given to you in the question, but this one, we assume you know these 3. Please ensure that you know these 3, or the possible outcomes of these 3. So in a standard card, we have from ace to, this stands for like 1. Okay, ace 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have king, we have queen, and then we have jack. Okay, so for each of the card, and we have 4 suit for spade, diamond, spade, diamond, what again? That is 1. That is 2. Club, that is 3. And art, yes, and art. Okay, that is 4. So for spade, each of these 4 suit has these 13. They are in 13 form like this. They are in 13 pieces like this. So the spade has ace up to jack. The diamond also has the same 13 type like this. Club also has 13 type like this. Heart has 13 type like this. Okay, please take note of that. That is a standard card. Okay, now we want to find a full house where we have one kind, 3 of one kind. So that means out of these 4, we want to choose 3. So we have 4 combination 3. Then after that, we also want to choose 2, 4 combination 2. But don't forget, each of these has 13 types like this. So that is why we have, for the first one, we are choosing 3 multiplied by 13. And then for the second one, multiplied by 12. So after we chose the one, then we have 12 ways of choosing the other one. That's why we are multiplying by 12. At first, we have 13 ways. But after the first 3 kind we chose, then we have 12 ways to choose the other 2 types. So that's why we have 13 multiplied by this, multiply again by 12 multiplied by this. Now, that is the event. The event of the 3 kinds we are choosing. Don't forget, our event is now 3 kinds, 3 of one kind, and 2 of another kind. 2 of another kind. Okay, that is our event, 2 of another kind. That is event E. So our probability of E will now be the number of that over the number of the sample space. What is our sample space here now? Look here. we are choosing 3 and then we are choosing 2. So our sample space will now be 52 combination 5. Okay, lest I forget, the card I was telling you about, everything make up 52. So we have 52 cards there. We have 52 cards with 4 suits, and each of the 4 suits is in 13 types. Okay. All right. So now this is our probability of the full house, probability of the full house, probability of our full house is now 13 multiplied by combination 4, 3, multiplied by 12, multiplied by combination 4, 2 over 52 combination 5. All right, so we need to open up this now. Don't forget combination. So this will now become 13 multiplied by 4 combination over 3, 4 rather, over 4 minus 3 combination, 3 combination, 3 factorial rather. So multiply by 2, multiply by 4 factorial, 4 minus 2 factorial, 2 factorial. Okay, all over 52 factorial over 52 minus 5 factorial, then we have 5 factorial. Okay, all right, let's deal with this. So in order to find this, you don't need to open up the whole factorial. So look at me now, 13 multiplied by 4, I have 3 factorial here, so I can say, then multiply by 3 factorial. So I can stop at this 3 factorial up there. Then this is 1 factorial, then 3 factorial, this one. This is 4 minus 3, 1. Then multiply by 12, multiply by, this is the highest one. So I can stop at that. Multiply by 3, multiply by 2 factorial. All over, this is 2 factorial, multiply by another 2 factorial. Okay. All over. Now this 52, but 52 minus this is 47 factorial. So that is the highest. So we have 52 multiplied by 51 multiplied by 50 multiplied by 49 multiplied by 48 multiplied by 47 factorial. I will stop there because the highest one at the denominator is 47 factorial, then multiply by 5 factorial. Okay, you see? So I can now use this to cancel this. Okay, take note that 0 factorial is equals to 1. 1 factorial is equals to 1. Okay, so this we cancel this. This is 13. So this also we cancel one of these. This 47 we cancel this one. Okay, so we can now simplify the remaining one and have 13 multiplied by 4. 1 factorial is 1. Multiplied by 12, multiplied by, this is 2. So 2 here and 2 here, 2. Multiplied by 2, multiplied by 3. All over. Now this is 5. This is 5 factorial. Okay, 5 factorial, I can open up that one. 5 factorial is same thing as 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. Okay, this is 5 and this is 2, 10, and 10 divided by this give us 5. You see? So this is 4 year 2, 4 year 26. Okay. Anyone there? So this is 2 year 1. This is 2 year 24. And 3 year 1, 3 year 8. Okay, so we now have 26 multiplied by 51 multiplied by 5 multiplied by 49 multiplied by 8 all over. All these are gone. Okay, Nothing is remaining here, so nothing all over now. So it's just there. Okay, it's just over that one. Okay, that is fine. So with this now, you can further simplify your answer, or you just simply press your calculator and then you get this. Of course, this and this goes with this one. Okay, that goes 13 year 1, 13 year 2. Okay, this is 1, this is 6. All right. Okay, so we have 18 all over 51 times 5 times 49. Okay, and you can press your calculator for that. Okay, that is fine. So, but take note of the possible outcome you can have in a card. In a card, I told you there are three main things you need to know in probability. Three main possible outcomes to know in probability: the coin, a die, and a card, a deck of card. You must know that that will not be given to you in any assessment. You have to know that on your own. All right. Okay. Okay, let's take this again. From a production run of 5,000 light bulbs, 2% of which are defective, one bulb is selected at random. What is the probability that the bulb is defective? What is the probability that it is not defective? Okay, so if you look at this question, how many light bulbs do we have? This 2% of which are defective. So out of 5,000, 2% are defective. So let's find 2% of 5,000. So the defective one, that is the defective, the number. So that means 2 over 100 times 5,000. All right. So we are going to have 100. So the number of defective is 100. The number of defective is 100. So the number of defective is 100. So that means the number of non-defective, the number of not defective should be what? Should be 5,000 minus 100. Okay, which will give us 4900. That is the number of non-defective. So now it is easy to find the probability. If you now have to find the probability of defective, so probability of defective is just the number of defective over the total, which is 100, over the total, which is 5,000. All right. So which is 1 over 50. Okay. Also, if you want to find the number of not defective, or the probability rather of not defective, just the number of not defective is 4900 over, what is the total again? The total is 5,000. You see, so that is the probability of not defective. Okay, that's probability of not defective. All right, but if you want to find the probability of not defective, you could also find the probability of not defective by, or you say the probability of not defective, the probability of not defective is just 1 minus probability of defective. You can also find the probability of not defective like that. So it will be 1 minus 1 over 50, which is still 49 over 50. So you can still find the probability of not defective this way. Okay, but you can still use the number of how many are the not defective over the total using our basic probability formula or definition. Is that okay? Please ensure you understand. Okay, so in probability, the property of probability, in probability cannot be greater than 1 and cannot be less than 0. So a probability of an event is less or equals to 1 or greater or equals to 0. So you cannot get probability greater than 0, less than 0, and you cannot get probability greater than 1. So if we are sure that the event will not occur, then the probability is 0. If we are certain that the event will occur, then the probability is 1. Probability of a sure or certain occurrence of an event is 1, while not occurrence of an event is 0. Okay, please take note of that. And the sum of the probabilities must be equals to 1. Must be equals to 1. Okay, must be equals to 1. All right, now we are dealing with what we call an odd in favor of an event. So the odd in favor of an event E occurring is given as this probability of that E over the probability of E complement. So the odds in favor, don't forget that, in favor of E occurring is probability of E over probability of E complement. That is the odd in favor of E. Okay, so if I'm looking for odd in favor of E complement, in favor, then it will be probability of E complement over probability of E. Okay, if it is odd in favor of E complement, then that will be the probability. Okay, all right, that is fine. Now sometimes they will give you the odds, and you will have to find the probability. You are going to be given the odds, so finding probability from odds. You are given odd and you are asked to find the probability. So if the odds that event occur are A ratio B, then the probability of E will now be A over A plus B. That is the total of A over A over B. That is the odd that E occurs. The odd that, so sometimes they give you the odd, they ask you to find the probability. Sometimes they give you the probability, you have to find the odd. Please take note of that formula. All right, so let's take this example. A student believes that the probability of getting an A on the next mathematics exam is 0. This. Probability of getting A. Probability of getting A. That is the probability of event A occurring, of getting A occurring, is 0 over or 0.2. What is the probability of not getting A? Probability of not getting A will be what? 1 minus 0.2. Okay, 1 minus 0.2, which will be 0.8. So the probability of not getting A is 0.8, while the probability of getting A is 0.2. So now, what is the odds in favor of getting A? Okay, what is the odd in favor of getting A? So the odd in favor, the odds in favor of getting A is just probability of getting A over the probability of not getting A. Okay, which is our 1 over 4. So that is probability of getting A over the probability of not getting A. Okay, so if I ask the question this way, what is the odds in favor of not getting A, What is the odd in favor of not getting A? That is just the probability of not getting A all over the probability of getting A. Okay, that is the odds. Okay, that is the odds. Is that fine? So which is 8 over 2, which will be 4:1. Okay, that is the odd in favor of not getting A. Please ensure that you understand. Thank you.